Hello, this is my Marking Period 3 screencast, which will be solving one of the problems that we learned about in electric potential number 2. Now, first I'd like to start out with showing all the equations for electrostatics. Over here is for electric force, here is for electric field. This one is for electric potential energy, and this one is for electric potential. Now, for the problem that I found, we're only going to be using these two ones, which over here. Now, here's the problem. A 2 kilogram cart with a 2 times 10 to the negative 4th coulombs charge starts at rest and moves 0.5 meters between two metal plates with a 20,000 voltage potential difference between them. The second plate has a hole in it, allowing the cart to pass. The supporting surface exerts 6 newtons opposing force of friction on the cart. How fast is the cart moving after it has traveled 0.5 meters across the 20,000 volt potential difference? Okay, pretend like you didn't see that. So here's the cart that has this charge. It's 2 kilograms, and the distance between it is 0.5. So the first thing that I did was I drew a bar chart. So you start out with a lot of electric potential energy, as you see here, because of the voltage difference. So that's important to note. So if you have a difference in potential, then you'll have a lot of electric potential energy. Oops. Then, instead of using internal energy, I put the friction as work, negative work done on it. And then finally, the remaining would go to kinetic energy. What I did next was I wrote out the equations and I simplified. So as I said before, you start out with electric potential energy with negative work, and you get kinetic energy. So, for electric potential energy, since to get electric potential, you divide out a Q value. In order to get electric potential energy from electric potential, you do the opposite and you'd multiply by the Q value. Henceforth, the electric potential energy would just be Q times the electric potential difference. So that is for electric potential energy. Then the work done would be the force that the surface exerts on the cart times the difference and times its displacement. And that would give you kinetic energy, which is 1/2 mv squared, as we know before. Then when you move everything over to the other side, you get velocity, this is lowercase, equals 2 times the value of qv minus the force of the surface on the cart times its displacement, all over the mass of the cart. Then, all you have to do is plug in your values and you'll get your answer. So, straight away the 2's cancel out. Then you're left with this. Oh, this should be 20,000 volts, not 2,000, so we'll add another 0. And then you get 1 meters per second as your final answer. Now let's go back. Hey, 1 meters per second was our answer. So that is the end of my slideshow. Thank you for watching.